And welcome to day 4 of Advent of Code 2022 done in Kotlin. Camp cleanup. Space needs to be cleared before the last supplies can be unloaded from the ships. And so several elves have been assigned the job of cleaning up sections of the camp. Every section has a unique ID number, and each elf is assigned a range of IDs. However, as some of the elves compare their section assignments with each other, they've noticed that many of the assignments overlap. To try to quickly find overlaps and reduce duplicate efforts, the elves pair up and make a big list of section assignments for each pair, your puzzle input. For example, consider the following list of section assignment pairs: 2 to 4, 6 to 8, 2 to 3, 4 to 5. For the first few pairs, this list means within the first pair of elves, the first elf was assigned sections 2 to 4, sections 2, 3 and 4, while the second elf was assigned sections 6 and 8, sections 6, 7 and 8. The elves in the second pair were each assigned 2 sections. The elves in the third pair were each assigned 3 sections. One got sections 5, 6, 7, while the other also got 7, 8, 9. This example list uses single-digit section IDs to make it easier to draw. Your actual list might contain larger numbers. Visually, these pair of section assignments look like this. Whatever that means. Some of the pairs have noticed that one of their assignments fully contains the other. For example, 2 to 8 fully contains 3 to 7. Yes. And 6 to 6 is fully contained by 4 to 6. In pairs where one assignment fully contains the other, one elf in the pair would be exclusively cleaning sections their partner will already be cleaning. So these seem like the most in need of reconsideration. In this example, there are 2 such pairs. In how many assignments does one range fully contain the other? So 2 to 4 doesn't have, 6 to 7 doesn't overlap. But for the third one, 5 to 7, it does overlap the 7 with the 8 and 9. There are 2 such pairs. In how many assignment pairs does one range fully contain the other? Okay, so we'll just need to check it for the single range here. Don't need to do anything with other ranges. Yeah, then let's get started. So we again get our list here. I'll start by copying the data. This is the example input. We've got an example check of 2, and we'll get my input from here. And we put this into there. So what we don't need to do is we don't need to consider the different sections altogether. We only need to consider one at a time. So we'll have something like an overlap. They call it contain. Let's call it val contains counter. Fully contains counter, which is set to 0. Oh, it's a var because we want to change it. And then we want to iterate over our line in lines. And we want to split it. And we want to split it by the comma and then most probably by the dashes. That means we'll say line.split with the comma, and this will then result in an array, and we'll say val first elf is gonna be line at the parts line 0, and the second elf is gonna be line 1. And now we will use a function to split those two, and we'll just declare a small data class for this, which we call data class, and this is start. It's gonna val start, val end, start, and it's gonna be an int, and we want to have a val end, and this is also gonna be an int, and we call this area. So then we want to convert this elfing. That means we'll just we can just put that into a companion object. We'll just part what does it even? From string? Autopilot sometimes does good things. Input, we want to also separate it with the dash. We're fine with taking this to an int, second thing to an int. That's cool. So that's exactly what we want here. So we can just call it area.parse from string, and we'll have this here, and we'll do the same for here. I think it's now complaining required line. Oh yeah, we definitely need to use parts here, not line, parts. So we've now set up our elves, and we'll now need to check if one area fully contains the other one. That means we can put the method here. We'll call it fun is fully contained, and we pass in another area, which is just call it other is super fine. I think even this is out. Our start must be fully larger or the same, and the end of us must be fully smaller or the same of the other range, and I think this is exactly what the fully contained would do. I'm just a bit questioning the val here on function. Yeah, obviously we don't do this. Yeah. And that means the thing what we'll now need to check is we'll just first elf dot is fully contained second elf, or the second elf is fully contained the first one. This is a bit weird what we got generated here. And then we'll say val full intersect, and if full intersect we would say full count, and then we say return, not here but here, return full contained to string. Not being very good of the naming, not being very precise with the naming here. So we have 509, and we'll submit that. Very good. On to part 2. It seems like there is still quite a bit of duplicate work planned. Instead, the elves would like to know the number of pairs that overlap at all, which makes sense. In the above example, the first 2 pairs don't overlap, while remaining 4 pairs do overlap. 5 to 7 overlaps in a single section with 7. 2 to 8, 3 to 8 overlaps all of the sections 3 through 7, and so on. So in this example, the number of overlapping assignment pairs is 4. In how many assignment pairs do the ranges overlap? So that kind of means that if we collect all our assignment pairs, which is assignment pairs are just two areas. No. And we now only want to know if we don't care if individual assignments overlap, right? But we care of overlapping different elves. Let me check that back. So 5 to 7, 7, 7 to 9, 5 to 7, 7 to 9 overlaps in a single section. Yes. 2 to this is the same like we had above, right? 5. That were only fully contained as well. Okay. Then 3 overlaps in all of the sections 3 to 7. Assignment pairs, do the ranges overlap? So we still don't need to consider different ones. The only thing we'll need to check is not the fully contained, but the overlap. So we'll just say we move it like this because we want to change our function maybe a bit. And move that to here. And in our case, we don't want the fully contained anymore, but we would like to have a partial overlap, which a partial overlap would mean that one of the following things must be true. Either I guess autopilot is doing it correctly, but we'll need to check it. So the start needs to be smaller than the start of the other one, and the end needs to be larger than the start of the other one. This would be the full intersection, and the end of the other one needs, and the end also needs to be larger than the start of the other one, which also makes sense. That would be an overlap. So we'll just basically need to check if either the start or the end point is between the start of the end point of the full other line. So and we do this here for the start point. I don't maybe even this code is correct, but I want to. So either our start is smaller or equal than the start of the other line, and in this case also, and the end must be larger than the start of the other line. The start. So we now just check if our start is left to the start of the other line, and the end is right to the other end, right to the other start. And we'll do the same with the end. We'll check if our end is left to the other end, and our we'll check if our end is one point needs to be in this section. I think this is the only thing we need to check. Yeah, and now we check if our end is to the left of the end, and Now we use the other answer. It's left to the other end, and our start is right to the other hand. Then this would mean we have a partial overlap, I think, right? Not entirely sure. So we'll just set up the data for it, and we'll give it a check if this is already okay for the. Then we want the partial overlap to be used here. This is not a full, this is a partial overlap. And it would just print ln the first, second partial overlap here. And we'll set our debugger to here and just debug it. This was wrong. We want to set it for the second puzzle. So we are here, we have a fully contained counter, which is still wrong, but we have a size of 6 and we got probably some output, which says false for 2 to 4, false for this one, but 5 to 7, 7 to 9, 2 to 8, 3 to 7. I think we can give it a try. And we have a fully contained counter of 870. Let's give it a try. Very good. So we now solved it, which is super cool. But I was not super confident with this one. I also accepted that we might have a wrong solution here. But let's just rethink what we wrote here. So it's working, but I wasn't really convinced why it's working. And this partial overlap function is not really doing what it's suggesting, and that's why we're gonna rewrite it. So why it was working was, this is just part of the condition we need to check, or so only covers basically one case, but the other case is covered by calling this function twice with other and this being swapped. But I think that's a pretty bad approach, and that's why we will rewrite this. So we'll take the is fully contained function we already have from example 1. And we will reuse this one here. So we for now cover if our line is fully contained by the other line. So we say is fully contained. We will also rename this to is fully contained by, because then kind of signals more what it does. This is one case. And the other case is that our other is fully contained by this, which means for now we'll just cover the cases where one line is fully part of the other one, and to have both cases covered, we call it in both ways, like we did for example 1. But we now have an additional case, and the additional case is the one I tried to explain before. And the additional one is that the start of the other line is within the start and the end of our line. This is exactly what this condition checks. So if one point and of the other line is within our line, then we also have an intersection. And the fully ones, where one line fully covers the other one, this is already covered by the above conditions. And we can now do this, and we'll just check the end, and we just check this for the end and the start point of the other line. So either the start point of the other line is within our line, or the end point is within our line. And now we have rewritten this partial overlap function. We should no longer need the second call here. So we put it away. And now we can rerun our puzzle. And we got the 870 again. And we also got the 4 for the example. So we now have some readable and code that actually makes sense. Yeah, thanks for tuning in. Bye bye.